Assalamualaikum and good day to our panel. I am Iyazi Shazana Binti Mohamad and I will present about the proposal for my final year project. The title for my final year project is the effect of Thermoplastics Nanosilica coating on mechanical properties of Kenaf and Arenga Pinnata fiber reinforced polymer composite. And my supervisor is Prof. Dr. Iyazi Shazana. Now, let's start off with the project summary. The annual global disposal of millions of plastic has increased demand for alternatives to non-biodegradable materials such as synthetic fiber. Growing public environmental awareness has led to numerous advances in the use of environmentally friendly materials in many applications. In recent years, natural fiber are being used to replace synthetic fiber as reinforcement in polymer composite due to their good properties and advancement to an environmentally friendly alternative. The use of natural fiber reinforced polymer composite is now widely used in engineering application as a replacement for synthetic fiber reinforced polymer composite. Therefore, this study will be focused on the development of natural plant-based fiber such as Kenaf and Arenga Pinnata fiber. The effect of thermoplastic coating, which is polyester sulfone, on the mechanical of fiber reinforced polymer composite made from Kenaf and Arenga Pinnata is investigated. The tensile, impact, flexural and interlaminar shear strength test is carried out to determine the mechanical performance and durability of the thermoplastic coating materials. Next, I will move on to the problem statement of my project. Natural fiber are known as environmentally friendly alternative to conventional fiber as reinforcement for composite material. However, it is relatively lower strength compared to the conventional fiber, and high moisture absorption are the major drawback of natural fiber reinforcement polymer composite. Therefore, this study is conducted to investigate the effect of the thermoplastic coating based on PES on the mechanical properties of fiber reinforced polymer composite made from Kenaf and Arenga Pinnata. The durability of Kenaf fiber is very low compared to Arenga Pinnata fiber, especially when exposed to high moisture. Therefore, this fiber are coated with a PES nanosilica thin film to improve their properties. Next, I will focus on the objective of my final year project. The first objective of this project is to evaluate the effect of polyester sulfone-based thermoplastic coating on mechanical properties such as flexural, tensile, impact, and interlaminar shear strength of Kenaf and Arenga fiber reinforced polymer composite. The next objective is to determine the effect of nanosilica filled polyester sulfone thermoplastic coating on mechanical properties of Kenaf and Arenga fiber reinforced polymer composite. With the literature review of this project. The first one is Kenaf fiber reinforced polymer composite. The Kenaf plant belongs to the hibiscus family. It is grown in India, Bangladesh, Malaysia, the United States, Indonesia, Vietnam, Thailand, South Africa, and other parts of the Africa. And Kenaf fiber as a reinforcing material has shown better specific properties than glass fiber due to its low density. Kenaf fiber and their composite have comparable specific stiffness of glass fiber, and the price is 3 to 2 times lower than the glass fiber. Kenaf fiber is a good reinforcement in fiber polymer composite due to its high strength and modulus of elasticity, high stiffness, low density, low cost and eco-efficiency, lower health hazard, renewability, good mechanical and thermal properties, and biodegradability. Next is Arenga Pinnata. Arenga Pinnata is a versatile palm species that can be used to produce a variety of food and beverage, wood products, biofiber, biopolymer, and biocomposite. As we can see in the table in the slide, shows the mechanical properties of synthetic fiber and the most common natural fiber. In tensile modulus, Sugar plum or Arenga Pinnata fiber exhibit better mechanical properties compared to some other natural fiber. Next is polyester sulfone-based thermoplastic coating and nanosilica. PES is the second widely used membrane material and MBR. It has a higher melting point and thermal stability than the other polymer membranes, having only 1% mass loss in air at 400 degrees Celsius. PES is more hydrophilic compared to PVDF due to its molecular structure that facilitates hydrogen bonding with water molecules. Therefore, a higher permeate volume can be achieved with the PES membrane. Nanosilica is the most widely used nanomaterial in both common cement and geopolymer to improve cement properties due to its reactive pozzolans and pore filling effect. Next, I will continue with the scope of my final year project. This research focused on the effect of polyester sulfone-based thermoplastic nanosilica coating on the mechanical properties of Kenaf and Arenga fiber reinforced polymer composite. PES-based thermoplastic will be used as a coating to the Kenaf and Arenga fiber reinforced polymer composite. The type of fiber that will be used in this research is a woven type of Kenaf fiber and Arenga Pinnata fiber. 4 different types of mechanical tests, which is a flexural, tensile, impact, and interlaminar shear strength, will be conducted to analyze the performance of Kenaf fiber and Arenga Pinnata with polyester sulfone-based thermoplastic nanosilica coating. Next, let's move on and look at the methodology of this project. This part will cover the material selection, sample fabrication, polyester sulfone membrane fabrication, and mechanical tests. The very first step is material selection. For this project, the fiber that will be used in this study are Kenaf and Arenga fiber reinforced polymer composite. Polyester sulfone-based thermoplastic will be used as a coating for Kenaf and Arenga fiber reinforced polymer composite. Next is the woven fiber fabrication process. Arenga Pinnata and Kenaf fiber will be used to produce a woven sample with a size of approximately 25 cm x 25 cm. The fiber will be woven manually as shown in the picture. The preparation of the membrane began with the preparation of the doping solution. The composite membrane PES were prepared according to the formulation of the ratio DMSC to PES is 84:16 weight percentage. The casting solution was first prepared by adding PES in the MSC. The solution must then be stirred at 60 degrees Celsius for 24 hours until it dissolves. Prior to casting, the resulting solution was degassed to remove a bubble trapped in the casting solution. A phase inversion procedure was used in which the solution were poured onto a clean and dry glass plate and then poured in using a glass rod with a fixed gap of 0.1 mm between the plate and the rod. The glass plate with the membrane film was immediately immersed in a solvent-free coagulation bath containing DI water to allow phase inversion to occur. The foam membrane was then transferred to a fresh DI water bath and left for 24 hours to allow complete phase inversion. The membrane were then washed with DI water and dry at room temperature. The last one is the mechanical testing. The first one is tensile test. The tensile tests will be conducted according to ASTM D5766. The Kenaf and Arenga Pinnata composite specimen with size of 250 x 25 x 24 mm and will be tested using an Instron 3382 universal testing machine with a crosshead speed at 2 mm per minute. Second one is flexural test. The composite specimen with size of 80 x 13 x 4 mm will be tested using an Instron 3382 universal testing machine with a crosshead speed of 2 mm per minute. The span length to sample thickness ratio will be maintained at 16:1. Approximately 5 specimens for each composite system will be tested and the average flexural strength and modulus will be calculated from the obtained value. Next is the interlaminar shear strength. The interlaminar shear strength test will be conducted using an Instron 3382 universal testing machine according to ASTM D2344. All the composite specimen will be cut into 36 x 12 x 4 mm strips. This test will be conducted at a crosshead speed of 2 mm per minute and approximately 5 specimens for each composite laminate will be tested to obtain an average value of ILLS. The last one is impact test. The impact test will be performed according to ASTM D7136. The composite specimen with size of 50 x 50 x 4 mm will be tested using an instrument Dynatube 8250 drop weight impact tester. The hemispherical tip impactor with a 13 mm in diameter will be used to determine the load carrying capabilities, energy absorbed, deflection, ductility index, and impact strength of the composite specimen. Next, I will proceed with the expected result. The first one is synthesis of PES membrane. In the study, the PES polyester sulfone membrane is obtained by the dilution method. The procedure for obtaining the PES membrane is described before in the methodology of this project. Next, I will proceed with the tensile test. As we can see, the addition of nanosilica did not significantly increase the tensile strength. However, the addition of nanosilica show a change in the resulting stress-strain curve. When the failure happened, the stress on the sample without the additional of nanosilica immediately dropped to zero. This is for the flexural test. The result indicate that the flexural strength follow the same trend as the comprehensive trend, and it was confirmed by other studies that the addition of nanoparticles increased the strength of geopolymer cement paste. The addition of nanosilica particle began to affect the flexural strength of the geopolymer. The last one is for the impact test. The effect of the nanosilica content on the impact energy of the concrete is shown in the figure in the slide. It can be seen that as the content of nanosilica change, the impact energy difference. This indicates that the nanosilica can improve the initial crack impact resistance of the concrete, but after the initial crack, the concrete continue to store energy. From all the graphs that we gained from the journal before, it can be said that the effect of thermoplastic, some nanosilica coating on mechanical properties of Kenaf and Arenga Pinnata fiber reinforced polymer composite can be predicted. That's all from me. Thank you.